Hey guys, welcome to day 16 of ratios. This is our second day of changing ratios, where we have something changing in our problem. Either one party is giving units away or things away, and the other party receives them, or sometimes somebody just loses stuff. Okay, so let's get going with we're going to do a few more today, and I'm going to have you do some similar problems in your homework, but we've got the ratio of the number of marbles in box A to that in box B is 4:3. If half of the marbles in box A are moved to box B, what will be the new ratio of the number of marbles in box A to that in box B? Okay, well, remember we're going to ask ourselves a few questions during changing ratios. When we have a problem like this, we want to know what the before situation is, what the after is, what is changing, and what question are we trying to answer. So let's take a look at our before situation first. So it says up here that the ratio of the number of marbles in box A to that in box B is 4:3. So let's go ahead and model that. And we've got 4 in box A. And we've got 3 in box B. Okay, so let's take a look at what our after situation is going to be. It says if half of the marbles in box A are moved to box B, so that's obviously going to be our after situation, right? Half of those marbles in box A are going to move down to box B. And then what's changing? Well, in this problem, both are going to change, aren't they? Because box A is going to give some away to box B. And the question that we're trying to answer is what will be the new ratio of the number of marbles in box A to that in box B? So let's go ahead and label this diagram before. And now let's go down here and label this after. Okay, so let's take a look at what's going to happen here. So we've got box A and box B. And box A is going to go ahead and give half of its marbles away to box B. So if box A gives half of its marbles away, half of 4 units is 2 units. And remember, box A is giving to box B. So box B started off with 3, didn't it? Oops, I didn't quite draw enough room there. There we go. And if it gains 2 units, well, it's going to have 5 units, obviously. Our question was, what will be the new ratio of the number of marbles in box A to box B? So now we want to draw our new ratio. Box A now has 2 units, box B has 5. We can't simplify that anymore. And if we take a look back at our word problem, I would say we definitely answered the question. Let's do another one. The ratio of Kylie's money to Grace's money was 5:3 at first. After Kylie gave $20 to Grace, they had an equal amount of money each. How much money did Kylie have at first? Okay, let's figure out what our before situation is. So we've got the ratio of Kylie's money to Grace's money was 5:3 at first. So we've got Kylie to Grace. Let's go ahead and model that. Kylie has 5. Grace has 3. Okay, what's going to be our after situation? So next in our word problem it says after Kylie gave $20 to Grace, they had an equal amount of money each. So if we ask ourselves what's changing, both things are going to change, right? Because Kylie's going to give some money to Grace. How much money did Kylie have at first? Wow. Well, how are we going to do this? It says after Kylie gave $20 to Grace, they had an equal, check that out, equal amount of money each. Let's take a look at our bar models, and let's not even deal with the $20 quite yet. We'll come back to that. But can we give some number of units from Kylie's bar model to Grace's that will make them have an even number? Right now, Kylie has 5, and Grace has 3. And I bet you can see that if we take one of these units right here and put them down here, they're each going to have 4, right? So let's do that. Let's give Let's take from Kylie's bar model. So now she'll have 4. And let's give to Grace. She had 3, but she just got an extra one from Kylie. So now she has 4. Okay, so now they have an equal amount of money each, right? Well, at least they have equal units. Now let's go back to that $20. So Kylie just gave 1 unit to Grace, right? Well, it also says that Kylie gave $20 to Grace. We can assume that that 1 unit that Kylie gave away was $20, right? Because she had to give 1 unit away. That's the only way they could have ended up with an equal amount of money. So that has to equal $20. So we're going to say 1 unit equals $20. Now the question I'm trying to answer is, how much money did Kylie have at first? Okay, so let's go back to our before graph up here. I should have labeled these earlier, but remember that Kylie had 5 units to start with, so that's what we're going to solve for. So 5 units is $20 times 5, which equals $100. Kylie had $100 at first. Okay, we've got another one here. Now I would encourage you to try to stop the video, see if you can solve this on your own, and then come back to it. Okay, the ratio of Sawyer's money to Cole's money is 2 to 3. After spending half of his money, Cole has $60 less than Sawyer. How much money does Sawyer have? Okay, well, let's go to our before situation here, and we'll model that first. So before, let's see, Sawyer has 2, and Cole has 3. And it says, after spending half of his money, Cole has $60 less than Sawyer. Okay, so our after situation is going to involve Cole spending half of his money and then having $60 less than Sawyer. And the question we're trying to answer is, how much money does Sawyer have? So let's draw our after situation here. Now we're going to have Sawyer and Cole. Now, do Sawyer's units change? Is there anything in that word problem to make us think that Sawyer's units change? No, there isn't. Sawyer is going to have 2 units after Cole spends his money, just like he did before. But here's the thing. Cole has 3 units. Is it very easy to divide 3 into 2? Now, I mean, we could divide 3 into 2, and we could say that Cole has 1.5 units, but that's going to kind of be a pain. And then we're going to end up having to multiply by fractions, and we're not going to do that. So let's do this. Let's find an equivalent ratio so that Cole can spend half of his units easily. Okay. Now, what we're going to do is we're going to subdivide here. So Cole now has 6 units instead of 3. If we subdivide Cole's units, we've also got to subdivide Sawyer's. So Sawyer now has 4. Here's why. If we do, let me just demonstrate with fractions over here. If we do a ratio like Sawyer over Cole, or we ask the question, what fraction of Cole's money does Sawyer have? We're going to get 2 out of 3, okay? I can't if I subdivide Cole's units here, and I don't subdivide Sawyer's, look what's going to happen. I mean, what I'm doing basically is I'd be multiplying Cole's units by 2, so I would end up with a completely different fraction, right? I'd end up with 2 to 6, which is not legal in fraction land. So I can find an equivalent fraction by multiplying by 2 over 2, but I can't just multiply the denominator by 2. That doesn't work. We all know that's not okay. All right, so now Cole has 6 units, Sawyer has 4. Sawyer still is going to have 4 down here on the bottom, right? But Cole is now going to give away half of his units. So he's giving away 3 of his units. And so let's go ahead and draw him with 3 units down here. I'm going to do that a little bit neater. Okay, now we're also told that after spending that money, Cole has $60 less than Sawyer. So if Sawyer has 4 units and Cole has 3, that 1 unit of extra that Sawyer has to equal $60. My pen is doing all sorts of crazy things here, you guys. I'm really sorry. Technology problems. Okay. So we want to know how much money Sawyer has, so we're going to solve for 4 units. 1 unit is $60. 4 units. And the reason I'm solving for 4 is because, remember, we subdivided, so we're going to go with that new ratio that we have. But 4 units is 60 times 4, which equals $240. Okay, here's another problem. I would encourage you to go ahead and stop the video. This one's going to be a little bit more challenging. So see if you can stop the video and try this on your own, and then come back and correct your work. Okay, so John and Matthew had an equal amount of money each. After John spent $25 and Matthew spent $18, the ratio of John's money to Matthew's money is 2 to 3. How much money did each boy have at first? So this is an interesting problem, isn't it? Because we still have a before and an after situation. However, we are not given the before situation in this problem, are we? We're just given the after. So we know they start out with an equal amount of money, but they're going to spend some, and then the ratio is going to be 2 to 3, John to Matthew. And we want to know how much money each boy had at first. So let's do this. We're going to start by modeling our after situation. All right, so we've got John to Matthew. John has 2 units, and Matthew has 3 units. Okay, now here's the deal, right? Remember that they spent some money to get to that ratio? So we're going to actually, and remember that at first they had an equal amount of money, right? So let's draw their bar models like that. Okay, I'm just going to draw a line here. So John had spent $25, right? So this money that he spent to get down to his new units of 2 or whatever is $25. And Matthew had spent $18 to get to that new unit, right? And they started off with the same amount of money. So after Matthew spent $18, it took him down to 3 units, and after John spent $25, it took him down to 2 units. So, notice that, Matthew has 1 unit more than John. So what we're going to do here is we're going to take the difference between the money that they spent, and we're going to assign it to that 1 unit. And that's how we're going to figure this problem out and figure out how much money that they had at first. So 25 minus 18 is 7, right? So this 1 unit right here is $7. Okay, so now we're going to solve for the amount of money that each had first. And actually, I'm not even going to draw a new bar model on this problem. So we decided that 1 unit is 7. So if we fill all that in, then Matthew started off with, well, he had $21 after. Whoops. And John had $14 after, right? Okay, so if John had 2 units after, that meant that he had $14. And we know that he spent 25, so to find his original amount, we do 14 plus 25, that equals 39. Matthew had $21 after, and we know that he had spent $18. So if we add 21 plus 18, we also get 39. Now, is that the same amount? And did we have the answer to the question? Yes, we did, because our Problem said they had an equal amount first.